here it is. This is the setup. Got it finished. Basically, it's all finished, ready to go. Got the microcontroller computer in there. Got my test mule saw, old home light mounted on there. There is the flywheel set up, the chain sprocket. Got a bigger sprocket on there for testing bigger motors, you know, like mini bike motors, dirt bike, snowmobile, motorcycle, whatever, for later on down the road once I get this Dyno running. So here is the RPM sensor. So it counts how fast that shaft is spinning, and it calculates what the horsepower and torque is of how long it takes to get up to a certain speed. It's able to figure all that stuff out through that. This is a brake lever, or a brake mechanism that if I decided to do a different type of testing, this dyno is what they call an inertia type dyno, and it is one way to test. And there's another type called a Prony brake, P-R-O-N-Y brake dyno, and this has a brake caliper mounted on this arm that moves, presses on a load sensor. Load sensor sends back a signal of how many pounds of pressure or grams or whatever of pressure is pushing down on this when I apply the brake. This is the brake mechanism. I kind of had to invent a way of doing that that was going to be with a little extra leverage, and so it wasn't real hard to push, but that's what applies the brake and slows this down and causes the load sensor to get a reading. There are other sensors on this too. This goes under the spark plug on the head. It's a temperature sensor to measure the head temperature. This is a proximity sensor for measuring the RPM of the motor. This goes right next to the spark plug wire. There are some other sensors built into the box, the computer box here, that has atmospheric temperature, humidity, or I should say atmospheric pressure, temperature, the barometer, the humidity, all that, and it can be used in calculation corrections and whatnot. And then the computer sits up here on the little stand that I made. It's I can turn it to, you know, if I'm standing over here and operating the saw, I can rotate it out of my way. I can remove it completely off of the back here. Sometimes I may end up redoing that because it's a little awkward having it in the position it's at, but I didn't want to have it over here at this end where oil was going to be flying around. So I may adapt that differently later on or modify it, but I have a tray underneath to catch the oil drippage. There is a splash guard up on the front for the oil. As the oil is slinging off of the chain, it hits this little deflector. Sorry, you couldn't see it. So it hits this deflector, and it just runs down and drips down onto that pan underneath. So this is where we're at with it for now. I've got to finish running this saw and getting my calibrations, and it records the data on the saw, or I should say on the laptop. It records the data. It looks at the RPM of the motor, the RPM of the the axle shaft, the flywheel, puts out different readings as far as horsepower and torque. So there's a lot of things going on. Once I do a power run and it starts doing its analysis, after it's all done and it comes to a stop, I shut the saw off. Well, actually, I don't have to shut the saw off. I can still get a reading while it's running. But that is it. So that is, next time you see it, it'll actually be running, and I'll do a test so you guys can see what it looks like and see what the program looks like with an actual run on it. But unfortunately, I gotta close shop down today and wrap it up. So I will talk to you soon. See ya.